Hello and welcome back to Cat Science and Maths. This is the channel that will take you from the beginning of your GCSE course in Maths and Science all the way to the very end in short, easy, digestible videos. This is Chemistry Lesson 3 and today we're going to be looking at the topic of isotopes. Some people do find isotopes confusing, but hopefully within about 2 minutes time we'll have changed all that. So in the last couple of videos we've looked at atomic structure and we've used this kind of format where you're presented with an element that has a mass number and an atomic number. And we've got quite good at recognising the number of protons, electrons and neutrons in each atom. So for this atom, its atomic number is 6, it will have 6 protons and it will have 6 electrons. And this atom will have 12 minus 6, remember the difference between those two numbers is your number of neutrons. Now this is carbon, but what we don't often focus on when we're teaching elements in class is the reason this is carbon is because it has an atomic number of 6. What do I mean by that? I mean it's the number of protons that defines what element you are. Really, this number of neutrons that's taken us up to a mass number of 12 is irrelevant. I could have more neutrons, I could have less neutrons. It doesn't matter. As far as we're concerned at GCSE, it just doesn't matter. All that matters is the number of protons, and that will define your element. So hydrogen is any atom that has 1 proton. Carbon is any atom that has 6 protons. Oxygen is any atom that has 8 protons. So how could carbon look different? What would a different version of carbon look like? Well, it's possible that out there, and in fact it's not possible, it's a fact that out there in the air floating around are atoms that have 6 protons. Okay, so we'll write this on the side. They've got 6 protons, which makes them carbon. They therefore have 6 electrons. But when it comes to neutrons, rather than having 6, they have 7. For whatever reason, the way the atom formed, they have 7 neutrons. And what's that going to do with their mass number? Well, 6 plus 7, remember the number of protons and neutrons is your mass number. Instead of being 12, like it was here, we've got a mass number of 13. But they are both carbon because they have the same atomic number. They have the same number of protons down here, which is 6. And that's what defines you as an element. When you do your physics, you'll see a radioactive version of carbon, which is carbon-14. And in carbon-14, again, we have 6 protons because it's carbon. We have 6 electrons because we have the same number of electrons as protons. But you can see we have 8 neutrons. That's the difference between the two. So if I said to you that this carbon here, carbon-14, this carbon here, we call carbon-13, and this carbon here, carbon-12, if I said to you that they were all different versions of carbon, you'd probably understand that. Okay, you'd probably go, oh, I get it, they're all different versions of carbon, and they're all carbon because their atomic number's the same. Well, when we use the word isotope, we really just mean that word version. These are versions of carbon, but they're also isotopes of carbon. Just think about that as your definition. It's not a textbook definition, but it will really help you understand it and not get confused about it in future. So let's have a look at some more isotopes because it's not just carbon. We'll come back to that one in a second. These are isotopes of hydrogen. If I was to look at this one here on the left, I can see that it has 1 proton, 1 electron on the outside, and actually it has 0 neutrons, no neutrons whatsoever. But what makes it hydrogen is the fact that it's got that 1 proton. If I look in the middle, this element here, this atom here, also has 1 proton with the positive charge. It's got 1 electron on the outside. And we can see a big yellow neutron. It's got 1 neutron. So it's the same element. It's a different version of hydrogen because it's got the same number of protons. It just happens to have an extra neutron. And this one over on this side here has 1 proton, 1 electron, and 2 neutrons. So they're all just different versions. Now, what type of question might you get based on that? You might get shown 3 diagrams like this, and it might say, explain why these are isotopes. And the explanation is always the same. 2 marks. The first mark is they have the same number of protons, and the second mark is they have a different number of neutrons. Now you can say that in a couple of different ways. You could say the same number of protons but a different number of neutrons. Or you could say the same atomic number or a different mass number. Because if we look at the atomic numbers of all 3 of these, they're all going to be 1 because they've all got 1 proton. But the mass number of this one will be 1, the mass number of this one will be 2, and the mass number of this one will be 3. So both those definitions fit. Either the same number of protons, different number of neutrons, or same atomic number, different mass number. Now sometimes you will be given 3 elements like this, but one of them will have a different number of protons. And it will say to you which 2 of these are isotopes of each other. And in that instance, you're just going to look at the 2 that have the same number of protons. So it will be atom 1 and atom 3 will be isotopes of each other. Atom 2 will be a completely different element because it's got a different number of protons. Now, sometimes isotopes make things a little bit confusing. You may have looked at your periodic table in the past and you may have realized that chlorine, for example, has a mass number of 35.5. And that doesn't seem to fit what we've said so far, because if we just pen this, we've got 17 protons, we've got 17 electrons, okay? But how is it possible to have 18.5 neutrons? It's not possible. Now, it turns out that when we look at our periodic table, every single element has isotopes, and the one we see on the periodic table is the most common isotopes. For the elements we deal with, usually one isotope is just way more common than all the others. You know, it makes over 90% of all that element. But sometimes we get elements where both isotopes are quite prominent, and we take an average of the mass numbers to reflect that, and that's what we've done with chlorine. And I'll show you the maths on that in a second, because especially if you're doing higher tier, it's something you're going to have to be able to do yourself. But basically, there are 2 isotopes of chlorine. One has 18 neutrons to give it a mass number of 35, and one has 20 neutrons to give it a mass number of 37. And they actually have this split in nature, okay? So we have 75% of our chlorine atoms have a mass number of 35, okay, and 25% have a mass number of 37. So how do we arrive at that number of 35.5? If you're good at maths, and I just use the term weighted average, you might just pick that up and run with it. You might know what you're doing. If you don't know how we arrive at 35.5, you don't know what a weighted average is, it's very, very, very easy. So you might be given a question like this, and it might say, calculate the average mass for this, or for these isotopes. What is the average mass? Well, all I'm going to do is multiply the percentage I'm given by the mass number for each side. So 75 times 35, and I'm not doing this in my head, I worked this out earlier on, is 2,625. On this side, 25 times 37 is 925. 925, there we go. And I'm going to add those 2 numbers together. So 2,625 plus 925 gives me 3,550. Now what we've effectively done there is taken 75% and added 25% of the other mass number, and we've now got 100%. What we want to do is divide that by 100 to get our average for one atom. So if I divide that by 100, that gives me 35.5. That might seem a little bit complicated, but I'm going to give you another go on this next slide, and we'll work through this together. So you may sit down on the exam paper and it might say a particular substance has 80% of its atoms with a mass number of 20 and 20% of its atoms with a mass number of 23. Okay, so it's obviously got 3 more neutrons. What is the average mass number? So let's think about what we did before. Remember, we said we're going to times the percentage by the mass number. So 80 times 20 is 1,600. 20 times 23 is 460. And I said we were going to add those 2 together, which gives us 2,060. And we are going to divide that by 100. And that gives me an average mass number of this element of 20.6. So that's isotopes done for you. Hopefully it's not too difficult anymore. Just remember the definition. It's an atom of the same element with the same atomic number but a different mass number, or the same number of protons and a different number of neutrons. The weighted average bit might take a little bit of practice, but all I can say is good luck. Now, if you found this video useful, please consider hitting that subscribe button, and don't forget, if you click on the playlist button, you'll be able to see videos just like this for biology, chemistry, physics and maths. And don't forget that patrons of the channel will not only have a say in what videos are made next, but you'll also have the opportunity to send me questions about your GCSE studies through the Patreon app. So all that's left now is for me to say good luck.